It looks to me like we had at least 3 big ideas about energy transfer, particles and kinetic energy. Can you tell us about the first big idea?
The particles that make up matter are in constant motion, therefore they have kinetic energy. The higher the kinetic energy of the particles, the warmer that substance is.
What about energy transfer between particles? How does this happen?
One way that energy is transferred between particles is called conduction. This happens when particles with different energy levels collide or hit each other.
So, if a high-energy particle collides with a low-energy particle, what happens?
Energy will flow from the higher energy particle to the lower energy particle. After the collision, they will have equal amounts of kinetic energy. This is our big idea number 3.
Those big ideas sound pretty important. Now is a good time to write them down. Let's review.
Big idea number 1, the higher the kinetic energy of its particles, the warmer the substance.
What you are saying is higher particle Ke equals warmer substance.
You got it. Now big idea number 2, when energy transfers between particles through collisions, we call this
conduction?
You are on a roll. What about big idea number 3?
Energy always flows from particles with higher kinetic energy to particles with lower kinetic energy.
So then, will the energy flow from cool to cooler or cooler to cool?
What? Question mark.
You can't just think hot and cold. You have to think about the Ke of the substance's particles, which would have higher particle Ke, a substance at -10 degrees Celsius. Or a substance at -32 degrees Celsius.
-10 and -32 Celsius are both cold?
That's my point. Don't think which one is hot. Think about the Ke of the particles.
Well, let's see. -32 is colder than -10. So, then its particles must have lower Ke than the -10 degree substance. So the Ke flows from -10 substance to the -32 substance.
Very good, old man. But now, I've got a few more ideas for you to think about.
Does this have to do with thermometers?
Yes, it does. Thermometers measure the average Ke of particles. It does this through expansion and contraction. As the thermometer particles collide with the particles of the substance you put it in, Ke gets transferred. If the alcohol particles inside the thermometer are gaining Ke, the alcohol will expand. If they are giving up Ke, the alcohol will contract. This will continue until the average Ke of the alcohol particles is the same as the Ke of the other substance's particles. Then the alcohol won't expand or contract any more. The number of particles gaining Ke is equal to the number of particles giving up Ke. No more temperature change. The substances have reached equilibrium.
Temperature is the average Ke of particles. When temperature doesn't change, it means the particles all have the same Ke.
Close? Energy transfers are still happening. But, the number of particles giving up Ke is equal to the number of particles gaining Ke.
At your tables. Green person summarize energy transfer. Pink person summarize energy flow. Yellow person equilibrium. Orange person thermometers.